I didn't record any of that. So now anybody that opens up the video because they didn't attend lecture starts to panic and wonder what did he say before he started recording. And you all know how important that information was, and you absolutely did not want to miss that. Okay, so where we ended last week was looking at the periodic table, coming up with different patterns. Because the afternoon section got a little bit further, I think I'll go back. We just looked at what solids, liquids, and gases were in here, right? That's where we ended. Okay. So what patterns do we see on the periodic tables up on the boards as far as solids, liquids, and gases go? Do these periodic tables give us any information about those phases? So someone mentioned colors. What's up on the board has no color as far as I can tell. So the projectors don't have that information, but the periodic tables to the walls do have the information. Right? And you'll notice that we have some colors incorporated. We've got black, red, and blue. Our red elements, those of you from home can now see. We started at 8:25, right? Did I mess that up? Just making sure. Okay. Our red elements are all of those guys. Whoops. Oh, sorry. And also hydrogen. And then we've got our blue elements, very limited, bromine and mercury. What did those colors symbolize? Okay, our individual phases. What was the red color? Gases. And its natural state. So it's always fun to kind of come up with what natural state means. Okay, remember how I said science or chemistry is a really broad field? Depending on who you talk to, their standard state may be different. Okay, so one of the things that, as far as these elemental states, what we're looking at is room temperature and atmospheric pressure. Okay, so one, can't put in numbers yet. The pressure that we would feel at sea level. Okay, so at those conditions, everything in red is a gas. Everything in blue, which I know shows up horribly on this projector, everything in blue is what? A liquid. Oh, well, that got rid of the blue. That wasn't supposed to happen. So blue shows up a little bit better now. And everything that I didn't highlight, just our standard black, happens to be what phase? Solids. Okay? You'll notice our periodic tables on the sides also have things kind of just outlined as opposed to filled in black. I'm not going to bother to highlight those on the tables in the projector. But what did those mean? Sorry? Synthetically created. Yeah, that's what it was. I already forgot. Okay? So as far as periodic elements, those are kind of some of the simple patterns that we could evaluate and kind of take into consideration. Beyond that, our periodic table also gives us some other information. Okay? The simple one that's given in your textbook, at least in this chapter, is looking at metals versus nonmetals. Okay? So where's that division? Anybody know a metal on the periodic table? Go ahead and identify it for me. Okay, I heard silver, which is Ag, gold, which is Au. I think I heard nickel, which is Ni, not to be confused with N. What is N? Nitrogen. They both start with the same two letters, so be careful with that one. What other metals? Oh, geez, tin, Sn, copper, Cu. Okay, aluminum. This is fun. You guys are all picking the ones all in one tight little area. How about any of these over here? Are those metals? Okay. All of those are metals. Mg is magnesium, calcium. Okay, all of those are metals. I think I heard a titanium in there too. Okay. Where's our line between metals and nonmetals? Okay. Staircase is a good way to refer to it. You'll notice there isn't a staircase drawn on this one, pseudo-intentionally. Okay. There is a staircase on our other one. I'm not sure if black's a good color for this, but I'll try. that kind of divides the periodic table. Okay, on one side of that line we have metals. Guess which side of the line that is? The left side. And on the right side of that we have, we aren't looking at phases at this point, it's metal and non-metal. Okay, we're trying to be as simple as we can with this. Okay, we wouldn't look at a phase, because if you look across that line, it's nice and black on our two boards. If we look in that upper category, that upper right-hand side, we see all three phases show up in there. Okay, so just because we're a non-metal doesn't mean it's a gas or a liquid or a solid. Okay, it can be any one of those.
I know the chart, but the book shows that uranium is also a semi-metal.
So what happens with our categories? So as far as we've got classified, we've got metal and non-metal. Is there a third one that's listed? Okay. What I've listed as metalloid, because I think metalloid is fancier or cooler way to say it than the textbook, I believe, refers to it. The textbook refers to it as a semi-metal. Okay. So what's happened is that in that transition along that staircase, there are elements that reflect characteristics of nonmetals and characteristics of metals. So they kind of cross that gap, they bridge it. Okay? Those extra species, because of their varying properties, are sometimes particularly interesting for science. Okay? One of the most common ones that you've seen everywhere, silicon. Okay? It's the properties of it being both a metal and a non-metal that allow it to be very interesting and useful for all of our technology. Okay? So our metalloids kind of bridge that gap, and I'm not the best at having these memorized. Okay, so I'll color these in purple: boron, silicon, germanium, arsenic. Whoops. Oh, I did have that right. Antimony, tellurium. Yeah, I was coloring that in right. Polonium, and astatine. So those compounds kind of bridge the gap between the two. So you get both metallic characteristics and non-metal characteristics. Okay. As far as all of that information that you need to memorize, how important is it going to be to memorize all of that? So if we take a look at metals versus non-metals, is it really important to memorize where that line is? Take a look at your periodic table. Every time you take a test in this class, what's going to be up on the walls? Periodic table. And that periodic table shows you the line between metals and nonmetals. So you don't need to memorize that line necessarily because it's given to you. Okay? It's already in this class. The part that's going to be a little bit trickier is exactly where those metalloids fall. Okay? So that's where I personally would spend a little bit of time to try and memorize that pattern. To me, I see 1, 2, 2, 2, 1 kind of staircasing on its way down, sort of sandwiching around that. Okay? Come up with your best method to try and get that line memorized. You don't necessarily need to know what elements are on that line because you have the staircase already. If you can remember the pattern, you just need to match up what those elements are. Okay? Kind of makes sense. I saw your hand in there. I think I saw you.
I just was wondering, this one, some of the semi-metals are on this side and some of them are up here.
It's on that bridge between metal to non-metal. So they're going to be somewhere along that line. Where exactly on it is hard to say. When you're looking at the metalloids, it's kind of a gray area. It does come back to the materials. So those physical materials and what they apply best to is kind of how we determine that line. Yeah.
What is the best way you suggest studying these? I mean, I know it's a lot of memorization, but
Studying which?
just any of the elements.
So figuring out the elements?
Yeah.
I personally would try and set up flashcards and just kind of scan through them. On Canvas, there's that handout that lists all the names. You could print out a whole bunch of copies of that and just go through and just start. Hydrogen is H. Okay, and just list them through as you go through in practice. There are PowerPoint slides that are available online. I think, that allow you to go through and click them. When it gets to more complex structures, and we'll talk about those a little bit, you're also going to be required to memorize some of the common ones that you'll see, okay, some of the larger structures. Those I actually have a slideshow for that you can click through and it'll give you the name and or the structure, and you have to come up with the name. Okay? I don't have anything for all of the elements yet. Okay? I can try and put that together, but it's kind of making flashcards. That's going to help you memorize anyway. Okay? Other things that you can do is start to read up on individual elements. The more information you know about where they're coming from or why they exist or their different phases, it tends to make it real and you tend to remember it more. Okay? So you can think about where those materials show up in your everyday life. Okay? So start to evaluate that information.
I was just going to say there's a website called Quizlet, and you can type in and make your own flashcards.
Oh, okay. Quizlet, did I spell that right?
I think so.
.com or just Google?
.com, I think, yeah.
Okay, so there you go. There's a useful tool for anything that you need to memorize. So apparently you can go into that and you can tell it what things you want to learn, and it'll generate those flashcards for you. Okay. Other questions? Okay. I've listed an extra little thing here. If we go to table 4.4, it lists out all the properties of different of your metals and nonmetals, which is actually supposed to be, well, not quite there yet. This is another periodic table, I think one that I'm probably going to purchase. It goes through and actually provides pictures of each of the individual elements in their natural state. So you could go through and evaluate each picture and see how it matches or how it compares to other elements within that section, both the metals and nonmetals. Some of them are going to be more difficult to take pictures of because they're in their gas state. So if you take a look at your far right, you've got helium, neon, argon, krypton, and xenon. Okay? All of those are gas states, as we can tell by our other periodic table showing in red. Those are typically used in, any ideas? In neon lights. Okay, why do we call it neon lights? Because those lights have neon gas pumped through them. And what someone actually noticed is that if we pump electrical current through that gas, it gets the gas really excited and it ends up releasing some of that electrical energy as light. Okay? The different colors we see are due to different properties of that individual material, which we will learn about this semester, or at least discuss to a certain extent. Okay? So I've got the link up there as well, so you can go ahead and take a look at this on your own, just to kind of get a feel for the different materials in there, what they look like. In some cases, you get pictures of who discovered them, okay, or who they were named after. So it was kind of neat. So this is a version of table 4.4, I think is what I listed it as, that lists properties of two particular species. In particular, our metals and our nonmetals. We don't list our metalloids because what's the issue with the metalloids? They carry properties of both. Okay, so it's in one case we might get something that conducts electricity better than another, so it doesn't quite match either definition. So we'll look at the extremes. One set of these is a metal, one set is a nonmetal. Okay? You know which is which? Metals are which? To the left. Our nonmetals are the ones on the right. What was the thing that gave that away for you? What was that?
I looked at luster.
Okay, we could look at luster. Okay, what is luster referring to? Kind of the shine. If we look at our nonmetals, you could look at carbon. There's a state of carbon that looks kind of shiny, right? What's that carbon state? Diamond. Okay? It has a high reflectivity. I don't think that classifies as luster technically. There's another state of carbon that we might be more familiar with. Coal or graphite. We have zero luster there. There's no shine. It's just kind of a dull, dry material. Okay? What else could we look at along those for big differences? So luster was one. What was that? could look at its physical state as far as how it holds up. Brittle versus malleable. Malleable means you can hit it and it kind of deforms its shape, okay, and flattens out. Brittle means when you hit it, it shatters. Okay? It breaks apart as opposed to just changing its overall shape. You guys are picking some hard ones. I would have started with the first one. Okay. How many gaseous metals have you seen? Not really typical to see a metal in its gas state. Okay. So if we take a look, our left-hand side says only solids. Our right-hand side says we can get solids and gases. Okay. Can we get a metal to be in the gas state naturally? No. Okay. To me, that was the easiest way to pick all the hard ones. Okay. You can also go through and evaluate a lot of these others along those same kind of underlying principles. For the most part, these are general properties that we would discover through experiment, kind of play around with, and we just grouped these according to particular patterns. Okay? They do not hold true for every single species, but they hold as a general pattern throughout the periodic table. Okay? Because I made this slideshow a little while ago. I don't remember all the metals up here, so let's see if I can cheat. Yes. Okay, what species have we got pictures of up top? Metals or non-metals? Metals. How do you know they're metals? Okay, they're all solids, but if we take a look at our non-metals, some of our non-metals could be solids. I could have picked 4 non-metal solids. So that's a good first approximation to set it up. What else would get it? We can look at the luster or the shininess. All of these are shiny. Okay? These do all happen to be metals. Anybody happen to know what metals they are? Sodium's not a bad guess, but unfortunately wrong.
Aluminum?
We've got potassium. So potassium, why did that not show up? Let's try that again. Oh, man. It's going to get rid of my cheat sheet. So we can take a look at, let's memorize those all real quickly. Got to be in the correct window for it to show up. We've got potassium on the far left. What's the symbol for potassium? Why is it not P? Okay. Phosphorus is symbolized as P. Why is potassium not P? Potassium was probably discovered first as a rough guess. Could be wrong on that. The K is probably coming from its Greek, Latin, or German roots. What's the next one? Nobody? Oh, silver. Not a bad guess. I tried to pick more interesting ones. MO. What element is MO? Molybdenum. Okay. It is found in different alloys. If you had a bicycle, there's a lot of frames that are chrome moly frames or bicycle frames. The molybdenum is used as an extra material mixed with the chromium to change the physical state of the two, and we get a mix between the two properties. It makes a typically lighter, stronger frame. So when we get on it, it doesn't break. Okay. Next one. Not a bad guess with mercury because that is pretty shiny. However, what was the physical state of mercury? It's a liquid, and I know the image isn't the greatest, but that's not a liquid. Anyone know that one? Ruthenium. Okay. Ruthenium doesn't have a whole lot of properties or interesting ones. It's typically classified with platinum as far as its chemical properties, I believe. It's very similar to what platinum has. So it's used in metal contacts and things like that. Sorry about that. I found ruthenium more interesting because it's typically used in organic chemistry. Okay? Ruthenium can be put at the center of several organic molecules, and it can actually act as a nice catalyst, and it can also act to resolve certain characteristics of other carbon compounds. So it's kind of neat in that respect. Very last one. kind of a mean one to look at. OS is osmium. It's actually fairly reactive with oxygen, which is why we see the bright colors on this material. In its standard state, or most standard states, we're looking at a single color for that material. In the case of the metals, we're typically looking at a silver, maybe even a gold color. Okay, why do we get this wide variety of different colors? Oxygen may be something that we need to survive, but it's also extremely reactive, particularly with a lot of metals. So what ends up happening is oxygen in the atmosphere reacts with the metal surface, and it creates a new compound. That's an osmium oxide. That new compound generates those colors. Okay? So we can see a variety of different colors depending on the chemistry of each of those materials. Okay? So let's see if we can come up with some more. What do you think these ones are? So someone's pointing out a potential for neon. Again, not a bad guess, but wrong. So what kind of species are these? Metals, nonmetals, metalloids? We're looking at the nonmetals. Okay? What nonmetals are we looking at? What was that? Radon. Not radon.
Silicon?
Sulfur is actually a yellow powder, not a gray one. Make sure I get my memorization down on these real quickly. We'll start with the first one because we heard guesses on that first. First one is actually SE. So if you've seen that really bad movie with aliens, technically it was supposed to be the poison to kill all those aliens. Forget which movie that was. Selenium, which was typically found for anybody that saw that movie. Head and Shoulders shampoo. Okay, apparently selenium is found in that. Anybody know what that bad movie was called? Evolution? That sounded reasonable. Is it just Evolution? Oh, okay. So see, we can even bring in science from bad B movies. Okay. Their science, if you ever happen to watch that movie or think back to their scientific thought behind why selenium was now toxic for the aliens, was awful logic, by the way. Okay. What's the next one? It's a little bit trickier. Heard someone saying iodine. It's in a little capsule for a couple reasons. One, it does generate a gas fairly readily. But what's the stuff at the bottom of that tube?
Silicon?
Nope. It's not a gas, and it's not a solid. What is that thing at the bottom? It's a liquid. We've got two options. I heard the one guess, Mercury, but where is Mercury on our periodic table? Mercury ends up being a metal. We're looking at our nonmetals, so it's not mercury, it's bromine. Okay, Br. Next image there, I heard someone say neon. Okay, not a bad guess again because you're picking the correct column. Okay, with an individual column, you would see similar chemical properties. So neon typically has this nice fluorescence color, but it doesn't give us this exact color. A different species gives us this one. This happens to be argon. Okay. The very last one may not be the easiest to see. Snakeskin, right? What element? Snakeskin. Carbon fiber. It's a carbon fiber. I tried to pick a picture of something a little bit non-standard. We're looking at carbon for that last one. And in that case, it was whoops, shouldn't have done that. Carbon is just the element C. Okay. Man controlled to generate that carbon fiber or grow the element in such a way that we generate a better material for what we need, okay, or what we were using it for. So that's not going to be its natural state. You don't walk out in nature and just see carbon fiber jumping out at you. All right? And the last one, you'll probably see examples of, what do you think? Metalloids. Computer works fast enough. Okay. What metalloids did we pick here? And these were kind of suspicious. So if we take a look at these, our initial guess might be that they were all metals. Why?
Just solid.
Okay. They're solids, and they're all shiny. Okay. Remember, we've got to be careful when we're looking at the metalloids because they have properties in both. Okay. A lot of those properties are things we're not going to be able to see. Okay. Conduction. How does it conduct heat or electricity? Until we actually test an experiment, we're not going to be able to visually see that. Density. Until we can hold that in our hand and have something to compare against or even measure, we can't see that as well. Melting points. Again, not the easiest thing to see. Reactivity. Okay, again. So we have to evaluate things a little bit closer. I wouldn't expect you to know these by picture. In general, I wouldn't expect you to be able to predict any of these based on pictures. Why? Okay, you do saw lots of overlap between these. These were all metalloids, and yet if we initially looked at them, we'd probably call them all metals. Okay? So based on a picture, you should be able to get a rough idea as potentially being a metal or a non-metal. Narrowing it down exactly as to whether it's metal, non-metal, or metalloid, I wouldn't expect you to do. So you'd want to do kind of that bulk categorization first, metal versus non-metal, and then kind of step away and see what other information you have. Which ones did I give you? Oh, because you would totally know all three of these. Okay. We have, I already forgot what the first one was. The middle one's probably the most important. Oh, come on. What is this thing doing? Middle one is silicon. What symbol do we have for that? SI. Last one is polonium. What symbol do we have for that? What was that? PO. Sorry, I thought I heard PL in there. And the very first one, oops. Antimony. Wait. Oh, yeah, sorry. We're looking at SB for the symbol there. Okay, now is the computer working? Okay, we're going to kind of do two things here. One, I'm going to see if I can